Okay. Well, thank you. Thank you for coming for one of the few English-speaking sessions. So you've obviously come for pain. Um, my name is Steve Poole. I work for a company called Sonatype, who you may know because they run this thing called Maven Central. And you may also know because they have this product called Nexus. But sometimes I feel that Sonatype is a bit quiet. So I spent a long time working at IBM, a little bit of time at Red Hat, and then going to Sonatype because one thing I'm really passionate about is Java security in all sorts of ways, and productivity and related things, but mostly because I want to teach people a little bit more about what's going on. Because as a Java developer, when I was a JVM developer at IBM, I ignored security. In fact, normally if you talk to a Java developer and you say security, you don't really know what it means. You might think about authentication or encryption, but not the bigger picture. So I was a Java developer, JVM developer. Then I took over a DevOps team for a couple of years, and I learned all about security, and I realized just how much we as developers don't know, and some of the many anti-patterns that we use. So this session is going to be a sort of what we call a sheep dip to try and give you some insight into what's going on. And we're going to use Log4Shell. We're going to talk through Log4Shell. I'll give you a demo. In fact, if you want to follow along, that's cool. I've got some instructions in a minute. But basically, we're going to look at the current state of cybercrime, cybersecurity. We're going to look at Log4Shell as a good example of the things that we as developers often get wrong. I'll give you a demo. We'll talk about that. I'll show you what happens there. And then I have another section where we'll look at some simple things, like 10 simple things that we could do, right? And believe me, I could spend days doing this. I've just come back from Dev Nexus, but I don't have COVID. And we spend a whole day there educating people. Right. Okay, so if you're interested, now or later, and I'll share these slides, if you're interested in following along or doing it later, you need Quarkus, not because it's Quarkus, but because it's got some really nice, the development mode is really fantastic for doing demos. You need Java 17, because we want to show you that this stuff is real, even on the latest versions. And of course, you need Docker, right? Because everyone needs Docker. And there are two projects. One is the Java Jeopardy project, and the other one is this thing which I'm calling Sly Server. And we may wander around some of the code to give you a sense of how this all works. But they use Docker because we have to set up services and stuff like that. Anyway, I've got this up and running. You definitely don't have to do it unless you want to. But in which case, you need to clone this stuff, compile it, and run Docker Compose, because stuff gets pulled down, right? And we know what the network's like. Okay, so I will do that later, right? So let's talk about trends. So a few years ago, when I started doing this, we had a view of what hackers look like, or what they did, right? We had this idea that they were some kid in their bedroom hacking things, taking over websites, doing silly things, right? And that's still true. They're out there. They're still doing these things. And occasionally they graduate to doing more serious things, which occasionally you'll see in the news of some surprised parents finding their children being taken away because they've been hacking the FBI or something. But it's not that, right? That's the trivial stuff. When I first started talking about this, and we tried to estimate how much the bad guys made out of cyber attacks, the number was pretty bad. When we started, 2014, thereabouts, the amount of money that we estimated that the bad guys got was about the same as the illicit drugs trade, about $450 billion. That was in 2014. and you think about how you perceive the drug trade, you think about how much it affects your lives, how much we spend on it, how much it pervades movies and things, we have this sense, oh no, drug lords burying money in containers, you know, truckloads of stuff, all that thing. And that's $450 billion. Ransomware, which is the bit where they get into your system and encrypt it, and then maybe give you the data back if you're lucky, that's $6 trillion on its own. You divide $6 trillion by the number of people in the world, and you can see just how much it's impacting us. Now, it doesn't come out of your, they're not going to steal it from you directly, but all this stuff impacts all the services that you use, and they pay. So your insurance goes up, your government costs go up, taxes go up, everything goes up because somebody is taking out this money. When you're talking about $6 trillion, and that's just ransomware, the estimate is that all in told, we're looking at maybe 20 to 30 trillion dollars being taken by the bad guys. And we'll talk about them in a minute, okay? That's where we are, okay? You can see significant reasons for people wanting to get involved in this because it makes them so much money. Right? And this may not be, maybe you haven't thought about it, but when we think about bad guys, we have this sense the further away they are, the less of a threat they are. And as human beings, because we don't see the bad guys, we think they're somewhere else. And so we have a sense that, you know, well, they're bad guys, but they live on the other side of the planet, so they can't harm me, right? And of course, that's not true, because it's between you and them, it's software, right? Because everything's online. They are literally next door. So this threat is real to you now. It's real to your business. It's real to you as a human being, as any of your online activities. You are possibly could get compromised by these bad guys. Because as I said, the only thing between you and the bad guys is software. And as we know, software gets holes in, software gets misconfigured. You just know that somewhere between you and the bad guys, there's a hole and they can get through. So it's not really about if they're going to get to you, it's about when, and then what can you do about it. And we'll get into that later on as we progress. Right. But so loads of money being made, lots of opportunity because it's all software, and we all know what software is like. Right. And this stuff is coming up everywhere. We have so many examples. Do not think of this as, well, it says software is everywhere in your life. Every part of your life is driven by software. Wherever you are, checking in here, checking a hotel, getting on a train, going to the supermarket, checking the time on or the email on your watch, software is an integral part of our life. And every part of that software is a way of getting to you. Because it's not just about a big, it's not like the doors are unlocked. It's like the doors are locked, but the window's open, or there's somebody knows what the key looks like, and it's all the small things. The bad guys are doing everything on this, right? Software in the car. Cars are being hacked. Car keys. So I have a BMW, I have a Mini, right? I got a BMW key. It has a vulnerability in it, and the vulnerability is that somebody can come along with a particular device and trigger my car key to unlock my car and start my engine. That's a real vulnerability. And do you know what the answer is? The answer is I put the car key in a metal box. Right? That's what they say. It's everywhere. Absolutely everywhere. Because software is everywhere. Wi-Fi. Okay, so how many people here are connected to the Devoxx Wi-Fi? You know? Okay, right. How do you know that the gateway that you're connected to is provided by this conference? Well, you don't. And because anybody could turn up with a device with a SSID that matches. Password's easily available, isn't it? You've got the password. That's easy to do. And I can force you to connect to any Wi-Fi gateway because the protocol allows me to force you to it. What I want you to start thinking about is how much you don't know. because we rely so much on all this software and we rely on how it works. Okay, that's just life. But you have to start paying more attention to how things work because they are the things that are going to bite you. Yeah, I think we've said all of that lot. So there are still all the bad guys out there doing what they did 10 years ago. Right? There's still botnets. Millions of devices get taken over to attack your systems. So it's not like the 15-year-old coming in. It's a million devices attacking your systems. There are still bad guys who want to steal your data, your credit card numbers, your national insurance numbers, your social numbers, because they're all worth money. That still goes on. And there are still people who want to ransom your data. They want to get in, encrypt it, and they want you to give them some Bitcoin. That still goes on. Right? You saw the ransomware numbers. It's big. The reason the ransomware is so popular is two reasons. One I'll get in a second, but the other one is that Bitcoin, anonymous Bitcoin or anonymous digital currency, means that you can be blackmailed, ransomed, and you can pay them and they won't get traced. Very rare. They occasionally get caught because they do something silly. And there are still cryptocurrency miners out there. They are everywhere. When you log into, say, a Wi-Fi using a browser, so you come to a hotel, you get a Wi-Fi, you log in, you get a little pop-up, it asks you, it's called a constrained gateway. They ask you to put in your details. That's JavaScript running. They've been hacked to do Bitcoin mining. Right? And Bitcoin miners, the hackers there, they don't want you to know. They're going to do it very quietly. They're going to steal just a bit of your CPU because they don't want you to know. So your build servers, they're great targets because we tend not to secure them and we're used to them running at very high loads of CPU. So that's what they'll do. Then they'll insert them in Docker containers so that the next time you bring up a service, a little bit might be, that CPU cost might be going towards these guys. That's what they do. And they're still there, right? But they've upped their game. We now have many, many instances of people compromising open source projects, getting into GitHub projects, taking over GitHub projects, turning up as nice guys, helping you to do something that you didn't really want to do. I'll do that pull request for you, I'll merge it, all those sorts of things, They get in, they help, and then they start sneaking in software. Or sometimes, very overtly, they just take control because the original owner says, I don't want this anymore, does anybody else want it? And they go, yeah, I'll do it for you. Thank you very much. You've now given me a way to deliver malware to some unknowing developer. Excuse me. Now, there are also fake packages in repos. Excuse me. They're up in their game. They're trying to get to the places that you trust to be able to get you to trust the stuff that they're putting out. They're trying to get malware or a similar into those places. So fake packages in repos. If you're in the node space, you will have seen this happening all the time now. I think it was last week Sonatype or week before Sonatype found 4,000 node packages have been installed using a bot, basically, automatically generated. And I'll talk about what they do in a minute. But they're going up the value chain, getting into the open source projects, getting into the places where you trust and subverting it. Build processes, because we tend not to secure them, we're not very good at this stuff. Developers tend to have build processes that are open to other people. We all share access to the build. Make some code changes, go press the build, or it's automatic, whatever. So another great place to get into is your build processes, because you can have the best security practices in the world, but if when you create that binary, it gets subverted at the point where you build it, then that's all pointless. And they will do that. They'll find those places where we're weak, where we trust, and we'll get in there. Right? Because they're not after money. This set of guys, money is interesting, but that's not what they're after. And these guys don't want to be found. These guys are there for long-term reasons, right? Because of this thing, cyber warfare. Now, this has been bubbling around for a few years. It's just not been particularly obvious. But over the last 18 months, 2 years, it has really turned the corner. And you can read now in the news. You can see in the situation with Ukraine. You can hear about it. Lots of instances of this happening. So cyber warfare is getting into your systems for control purposes, for disruption purposes, for misdirection, those sorts of things. That's what they're trying to do. Right. They're well funded, of course, because they're mostly being driven by state actors. They're well educated, again, because they are people hired. They are for their skills in thinking how to break into systems, right? And they have specific targets. So one of the things that we used to see, and we still do, so I should say we still use this stuff, is what you'd call a drive-by attack. And that's where lots of bots are probing your systems and trying to find a weakness. And if they don't find a weakness, they'll move on, right? Because what these people are doing are trying to get into the supply chain, and again, we'll talk about this later, what they're trying to do to get in, they're much more aggressive, and they will continue. And they'll do social engineering on you as human beings. You're a developer, you're a great person to figure out to do some social engineering to help them get their way, right? So they're lots of stamina because they have a specific goal to compromise the system that you're providing. We're all part of a supply chain, right? Everyone, we're all part of this. It isn't about it doesn't affect me because I don't know. I write software for a charity. Well, it's not only about what you do in terms of you're in the supply chain. It's about who you know. Because if they can get into your systems to get you to send an email to another system, relationships. They trust you. Oh, it's that group. They're really good. They want something. We'll help them. There's all sorts of ways you can be compromised. And of course, the obvious thing is they'll just steal all your data and impersonate you. Right? This is all real, all happening now. Right? You have to start looking up in your game. Right? Yeah, I think I've said this. Yeah, so all about the supply chain. This is the thing they're after. Funny thing is, as Java developers, we'll hear supply chain, and it tends to be this businessy thing. But actually, the supply chain is not only the business, but it's also the software supply chain as well. And again, later on, I want to talk through the consequences of how we have our own supply chain as developers and some of the things that'll be changing in that space. Right. So there we go. They want to get into. Did I do that? That's better. Yeah. They want to get into every service because the internet is the next battleground. If I can disrupt the train systems so that it can't run, can't get munitions to the battlefield, right? If I can disrupt the economy of the bad guys, of my enemies, well, you can see it makes it harder to do things. They're less likely to do what they want. I can steer them. We all know about fake news. This is the same thing, but rather than being influential, it's actually taking control. Getting into the pharmaceutical systems, into the transport systems, getting into the supermarket systems, getting into power stations. That's their ultimate goal, to get in there. So if and when they want to, they can manipulate or turn it off. Think how much disruption you'd have if for the next week none of the supermarkets have got food because they can't get delivered because they've been disrupted. Maybe the trains are down, maybe the motorway signal systems are broken, maybe the GPS in the trucks delivering are broken. There's all sorts of things they could do that would disrupt you. They're all workaroundable, but you can understand what the consequences would be. Here's an example of it really happening. Turning off train signals. Right? This is happening now. And the consequences of this happening now, and it has been happening for some time, to be honest, is that we're all beginning to catch up with the consequences of how we do software, how we think about software delivery, and because it's become a cyber warfare thing, that means it's become a state problem. So governments are now beginning involved, and they are going to start being involved in how we deliver software, right? It's just beginning. Last year, there was an announcement by Joe Biden about cybersecurity and implementing some changes to the way that software is produced. And I'll take you through some of that, because ultimately it's going to change the way that we deliver software. So, let me take you through some of these things again. Bad actors used to look for CVEs. They'd look for a report. There is a bug. Okay? And they'd go, it's been reported, therefore we'll go and exploit it. Sometimes they find them themselves, but quite often they would wait till these things got reported. So, you know, it was a bit weird. The bad guys would be waiting for you to leave the door open, and then they did, right? But they don't do that anymore. Now they make their own stuff. So there are 4 things on here. 2 of them are actually automatable and are being automated, and 2 of them require them talking nicely to you. So dependency confusion and typo squatting. So typo squatting is sort of what you'd expect. You type in a dependency and you get the name wrong. Just you transpose 2 letters. Now, in theory, when you try to build it, it would say can't find this dependency, doesn't exist. But actually what happens is somebody has registered a package with that typo in it. So you get their bad package. So they'll take the thing that you're expecting and they'll fork it and they'll change those names, just a couple of characters, and then you get their bad code as well. Now, in the node space, well, basically everywhere other than Java, to be honest, I'm sure people will shout at me for saying that, but it's about what's the process for proving that you own the right to publish something. And this is something else you have to start thinking about. When you consume stuff, how can you trust that the stuff that you're consuming is real and is solid and is reliable? Well, part of the process is, what are the rules for it being published in the first place? Some of the repos that you use will have some rules. So like Maven Central, one we all rely on, has some reasonably strong rules. For at least you have to own the domain of the packages that you're publishing. Other repos, like Node, I like to name some others, where they have no rules. It's anybody can publish them. You may take stuff from GitHub, all right? You just download stuff. There's no rules. So in places where there are no rules, then you have the bad guys updating things dramatically. So you get thousands and thousands of packages being pushed up there, sometimes with really nice names, sometimes where it looks sort of right. You know, I'm after the blah, blah, blah widget, and I find the blah foo widget, and I go, yeah, I got to do, because as developers, we don't pay attention, right? And the other one, dependency confusion, is when you don't understand the rules for pulling down dependencies. And one of the classics is some people are registering like you want latest. So what happens if you want latest, and between the real latest, package XYZ version 10, there's another one that somebody's registered with real name package version 9999. You always get that one because you've asked the latest. And people can do that in the right repos. Okay? And there are other variations of these, but you get the point. People exploit your lack of understanding of how the system works. They exploit the fact that you trust these things, because why not? It's just code. So that's one. And the other side, open source repo attacks is literally a load of social engineering. Loads and loads of ways of trying to convince you to give somebody access. Now, sometimes it's not even hard. Sometimes there are projects where people just turn up and go, hey, I've got a feature, can you take it? And they go, yeah, that looks good, thank you. All the way through to them being some process. The projects that have poor hygiene in these ways, development process hygiene, are being exploited. But they want to exploit everybody. They will be targeting the biggest open source projects that they can find that you use, because obviously that gives them the most opportunity, They tend not to exploit the sites, the smaller ones, because there's not much gain. Right? But having said that, what you think is most popular isn't necessarily what you think it is, because you're thinking about those dependencies that you might put in your POM at the top level, but of course dependencies have dependencies. So what's popular might be something that comes up three layers down in everybody's tree. Okay, so don't think it's necessarily, oh, it's Spring or it's this. It's like, no, not necessarily. Okay. So, and then the build tool attacks. Turns out lots of people feel that it's okay to let anybody trigger builds. And when you have those situations, you find these things can get taken over. Bad code gets injected. They press the build. New version pops out. So that means now you have to start looking at how the cycle of how often version updates take place within an open source project. Because if they're releasing one a week or like one a quarter, and then they do 10 in a day, not a good sign. You have to pay attention to this stuff, because whereas before mistakes were made because we're all human, now these aren't mistakes, these are deliberate actions to exploit your trust because you had a particular way of behaving. Right. Now, as if that wasn't bad enough, this is all downhill story, okay? Until we get to the bottom, and then I'll talk to you about what you can do to sort of keep the roof on your head. But it's not the greatest story. And actually, as Java developers, we're slightly better off because of the way that our ecosystem works. But believe me, some of the other places, it's just horrible. Now, who's heard of 0-day Windows? You know about 0 days? Okay. Well, okay. So, it's the time between when a vulnerability is published and it's first exploited. Right? You have to sometimes guess at this, but you get some sense. So back in 2006, I know it says 4, but it's not 40. It's like 45 days. It used to be somebody go, oh, I found a vulnerability. It'd get reported. It would get fixed pretty quick. Most people fix their vulnerabilities that are important very quickly. Not everybody. Something has to check, right? And then they get it out, and you'd have 45 days for your IT guys to apply patches. Okay, you can see we're all laid back about it. 45 days. And then over time, that came down and down and down. We got down to struts 2, which is the Equifax thing, and we were down to a matter of a couple of days. And then we got to log4j, or log4shell, and spring shell. And in fact, you may soon hear about another one that's just turned up, right? But we'll talk about that if we have time. But so we went from 45 days down to 0. 0 days is from publish to exploit, there is no time. Right? You're being attacked instantly. So soon as the bad guys hear about it, attack happens. You have no close, no window. Well, that's gone. People are paying people to suppress the discovery of vulnerabilities. Millions of dollars are exchanging hands just to keep one bad vulnerability from being reported, because of all the money they can make and because of these new reasons for doing this. Think about that. Some places require that anybody who finds a vulnerability reports the vulnerability to the government before, and maybe instead of, reporting it to the people who need to know, like the guys who own the code that's got the vulnerability in. This is a very lucrative space. Where we used to have bug hunters who were doing it for, they were white hats, they were doing it to find it for our own benefits. Now people are turning into bug hunting as being a profession because it pays well, and there are lots of tools out there to help you do this. And of course then there are guys who have the dark hats on who are going to the next level, and they're going, yeah, I know how to compromise the open source project, right? I'm working to get good credentials so I can compromise. These things are all available on the dark web. Okay. Right. So the more severe the vulnerability is, in that it gets discovered by these people, the less chance of it getting reported, right? But having said that, some of the vulnerabilities that we're seeing, like Log4j's been in the wild since 2014. We just haven't been paying attention. Right. So the new world that you have to get your head around is exploit first. So when you hear about a vulnerability, you have to fix it, right? There's no ifs or buts anymore, because not only will you have people trying to probe you and trying to exploit it now, there will all be people who've already tried to exploit it, right? And we can expect more and more of the situation where the exploit doesn't even get reported, because if it's lucrative, why would I do it? Right? You scared yet? You're going to run back and patch all your systems, right? It has consequences, doesn't it? And we'll talk through those consequences. Right. And I think I said this. Look, you can search for all this stuff. There was always, and there is always, an industry of people out there whose job is to test the security of your systems. They're called pen testers. You may have them in your team. You may hire them. But whereas it was a job to get into people's systems, now it's become even more lucrative, because now they're scanning code. They're looking for configuration errors. There's all sorts of things they're trying to do. And it is a good, solid, thriving industry. So don't think that the bad guys are poorly equipped, right? So they're highly motivated, very professional, have all the right tools, and they're here now. So what do we do? Well, last year, Joe Biden made an announcement. He did what all governments will do in this situation, where it got to the point that something had to happen. When it was just a commercial problem, right, it was sort of like, well, it's a money problem. Well, sort of let the capitalism sort it out. But once it became a state problem, an existence problem, we started to get more attention. So this executive order came out in May 2021, right? And it has a whole bunch of stuff in it that once you start digging into, it's a big report, lots of things. So they recognise that maybe we should do something about it. So you will have seen noises about various large companies in the IT sector going to the White House and having conversations, because we're trying to figure out what we're going to do about it. And that makes sense. And then they said, right, we're going to put the problem on the end onto the software developers, to the vendors. So the net is that by 2024, the expectation is that you won't be able to sell software to the US government, without having followed all their rules, and other governments are going to follow suit. So, at the middle of all of this, there's a thing called an SBOM. So the new term you will hear, software bill of materials. Right. So there are two standards. It doesn't matter which one you like, because they're both going to get used, because they all have pros and cons. But they're going to work around. So you imagine you have your POM, right, and you have a list of dependencies. Right. So that's your first level, and you know that your dependencies have dependencies, and those dependencies have dependencies, and so on. So nowadays, if we're looking, the way we try and find vulnerabilities in software is we try to figure out what you've got. And we do that by looking at the POM and then try and figure out what you pulled in, and try and figure out what actually you've got installed. The SBOM is supposed to reverse that. The SBOM is going to say, I'm going to publish a digitally signed document that you can use to prove that this piece of software that I'm giving you contains these things. Right? And then I give that to you, and then you can take that and you can create your own SBOM, digitally signed, that refers to that because it's one of the components, and whatever else you want in it, okay? And it goes up the tree. So that when we get to the point where a vulnerability is discovered, you will be able to know exactly that it affects you because you have an SBOM. And it won't be, have I got this software installed? You will know. And it's going to start off with just the software dependencies that we're used to, but it's going to grow. right? It's going to grow into having SBOMs for operating systems, SBOMs for compilers. So when the software that you produced you're using this version of Java, right? Well, that might have dependencies in, because the bad guys may be trying to compromise the compiler to insert malware, right? And that really happens. And I've got at least a couple of examples of log4j being used to do something like that, right? So eventually, this is going to be an example where every piece of software that gets produced, the tools that you use, will be part of this big chain of evidence. Now, we're nowhere near there yet, but that's where it's coming. Right. Now, it doesn't mean you have to do all this. So as you can imagine, everybody gets to do their part and produce the information, and you just bring it together. Because hardening this software supply chain is the first step towards beating the bad guys. It's not the only step for sure, but it's a big step. But connected with it is proof and evidence. So these are rules that are going to come down to you as a project. Of course, it's going to trickle down, and you may or may not be first on the list, depending where you are in the cycle. But if you provide software to somebody else, you may find that you have to do this because they require it for themselves, so therefore it will come to you. So you have to have evidence of an automatic vulnerability check process. Automatic's a big word in this thing. They want no human beings involved. Human beings are allowed to press the build button, but everything else will be automated, because if you have a break in a process where a human being does stuff, bad things could happen, right? So look, automatic supply chain process, automatically vulnerability check process, evidence of software integrity, SBOM and stuff like that. You demonstrate that you're running audit processes, evidence, strong controls, you know. Do you get the sense of what's going on here? So the big consequence of this, do you remember GDPR? GDPR turned up and we all went, oh no, we don't want to do this. It's going to be horrible. And a few companies turned up and said, well, we'll do it for you. So my estimation is that one of the consequences of this is that we're going to find that the build processes that we rely on are going to become less and less to do with what we produce, do it ourselves, and more likely to be outsourced to some other people who can do all this stuff for us, right? Because that will help keep our productivity up and still run these things. Right. Yes. So, things to think about. Industrialized attacks on you. This new way of getting to you, exploit first. So the bad guys don't give you time anymore. Government legislation coming in this side to hit you over the head because they want you to do a better job than you've been doing. It changes the way that we create software. It's going to change the way we create software, and it's going to change the way that we think about all the software that we consume. Not simply because they need to have a bomb, which will be the final thing, but it's also the fact that we can't trust them. You can trust them once you've built trust and you understand, but you can't automatically trust them. And I'll guarantee that everybody in here who's ever downloaded a piece of software has never thought about whether it's safe. Right? I bet you've gone, oh look, I tell you what the classic is, you go, I need a widget to do this. Google, Stack Overflow, I use this. Go to Maven, what's the Maven Central, what's the latest version? Cut, paste, does it work? Yes. Yes, that's what we do. But you can't do that anymore. You have to figure out how to prove to yourself that that thing not only does what it does, but is also produced in a competent manner, right? And is actually from the right people. And everything that depend on also fits those criteria. Right? Okay, you're all still here. Okay, so now I want to switch gears because I want to talk about this thing. Who heard of log4shell or logshell? Yes, log4shell. Yes, it's my fault because I work with a security researcher, and the day before this was announced, I was saying to him, can you just find me a Java one? Because all you ever find in Node. And then the day after, we got this. Right? Right. So I knew what I was doing on the 9th of December because I was moaning at him about, you know, why haven't I got a Java vulnerability that solid and big. Right? And then, of course, it just kicked in, blah, 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 got onto the TV, CNN put it on, other Fox got it on there, got to the US government and their organizations, It was sort of very timely for everybody to go, there, see, we told you, you got to fix this. Right. Log4Shell may be the worst ever vulnerability. And it's pretty true. I can explain why it's pretty true. Right. And then people started exploring it, and we started getting tales of how they were exploring it. So this particular one is changing the name of the iPhone to have the vulnerable thing is, and I'll give you a demo, we'll talk about the code in a minute. But change the name of your device so it gets logged and bad things happen, right? So there were some really inventive ways, right? And Log4j has definitely been used in situations as a front door, because it allows you to run code remotely. What you can do with it once you get into a system is do whatever you want. And so we have several instances of, for example, using Log4j to get into a build server to add some malware into the build process for creating firmware for some routers. Okay, and it sounds complicated, but that's what they're trying to do. That's what happens, and the bad code gets into the firmware. Okay. Let me give you an aside, because we talk about this and it sounds funny, but I was at a conference talking about this, and I told a story about compromised devices, and this person came up to me and they said, "Can I tell you about the TV?" And I had this conversation with it, and I put it back into the next time we did the talk, and somebody else and said that came up and said that happened to me. So the story is pretty simple. This company in the middle of nowhere, in the middle of west of the US, manufacturing industry type guys, had a Ethernet thing, and they wanted to have a TV where they could publish news what was happening in the company. So they bought a smart TV, plugged it in, perfectly worked, Ethernet cable, everything lovely. And then, just because they were scanning, they found they picked up a second SSID. So eventually they figured out that it came from the TV. So, turn the TV off, SSID goes away, turn it back on, it comes up. So this just, is like silly. So they phone up the manufacturers and say, how do we turn off this Wi-Fi? Because we don't want it. And they went, it doesn't do that. It hasn't got that capability. And they followed the chain through, and they ended up talking to the manufacturer of the TV over in China or Japan or wherever it was, who said, no, it doesn't do that. It doesn't have that capability. So being an engineering company, they took it apart, and inside this was a system on a chip, which is basically a little Linux box, right? And, yeah, it's got a Wi-Fi chip in it. Manufacturer of the TV says, no, it's not ours. So somewhere between it being manufactured and it arriving, it gained extra features. Okay. Now, you would expect probably it was the manufacturer, because they tend to pick these system on chips on price, and they don't really care what it does. But there was a wrinkle, because they also found out that when they turned on this TV, it phoned home. It pinged a particular IP address with its geolocation. So it wasn't a mistake by the manufacturer, it was the insertion of specific form of malware. Right? And this happens all the time. If I've got, the little USB dongles that you plug into the wall, the Apple ones, with the rechangeable heads? Do you know you can get those with GSMs in, phone chips embedded? There's a particular strain of corrupted hardware, USB things, which have this in. And you will protect that with your life, because it's a USB thing and it's expensive. And you plug it into the wall and you power it, thank you very much. You plug a USB cable in, which is probably a data cable, not a power cable, because you don't know the difference. And there you are, it compromises your system. Right? Now, why I'm saying this is because this is endemic, it's everywhere, and we pay minimal attention to this. Right, okay. So, oh look, this is the one. This is another one I was talking about, but Yeah, Deep Panda, Chinese hackers, other, installing rootkits and all that sort of stuff. That's why RCE's remote code execution is just so fabulous. Right. Okay. Now, log4shell has been there for a long time. It's a really embarrassing thing, actually, for the Java community, because it was some the hackers, I can't remember the conference now, but it came up at a hacking conference that this vulnerability existed, and it got reported, and everybody went, nah, won't fix it. 2014. Because it's ever so easy. So you have code like this. You've got login code, get a logger, and then you log stuff. That's what we do, and you've got substitution parameters with the curly brackets and things like that, and we log information because it's for logging, because it's there to help us understand what went wrong when things go wrong. Yeah. So when you fill in all that stuff, you get logs, and it has real data in, because everything gets replaced. That's what it's for. I'm not going to knock it for that. Right. So whenever I log, ID, whatever comes in, I put in the log. So the first problem, and it isn't conceptually a problem, but when you start thinking about it, it's like, I'm not sure how we're going to deal with this, but basically your logger, because you were logging information that came in from all sorts of places, direct and exactly as you got, because the whole point of this is you're debugging things, aren't you? So you don't want to change the data you got because it will tell you what's going on. So you write it directly via the logger into the log. And okay, bear in mind this is data from wherever it came from, right? And then sometimes you might go, well, actually, because I'm running my code, I've created a component, and I might need to know what version of Java it's running on or something else. So, I might do logger.info version and then do some code, right? We're all used to doing that. Well, log4j went, well, that's silly. We're all doing that. We'll add some system properties or some system variables, right? $bracket sys colon java.version, right? Sys colon means go and get whatever the next thing is as a system property. So whatever's in system properties gets reported, right? So if you run this, you get whatever version was running at the time. Okay. There are system properties you can put in there. There are environmental variables you can put up there. Env. You can publish where the log4j config is. This is all important diagnostic information. And then you've got all the other things up there, right? And you can add your own ones. But you'll notice JNDI, which is the one that turned out to be all the problem. But look, loads of them. Because if you're writing logging and you want to know information about something, if the logger will do it for you, why not? Yeah. Right. So, oh yes. And the other thing is, to be extra helpful, if the system variable that you've got, the $bracket, blah, blah, if the resulting string is also one of these, it will get re-executed. That's a small but critical thing. Okay, so here I've got an envar that's look, I have an environmental variable called mode, which has that on it. That's all it says. When I log env mode, I put that log4j picks up the sys version and then interprets that. That's an important part of this weakness. Right. Okay. So what we have is a very, very helpful tool that got extra help added, extra features, and for like the JNDI thing, so what happened was somebody wanted to be able to read data from a JNDI database source. So because you want to know how your database is configured if you're using JNDI to configure it. So again, it's just easy. Can I have that data, please? And that was very helpful, but nobody realized that by enabling JNDI, it also pulled in all the things that JNDI could give you, like LDAP. And so that's where it all started to go wrong. But then also, we wanted to make sure that whatever data came in, we wanted to write directly because it's for debugging purposes. And then we had this, for some obscure reason, we had this recursive substitution lookup. All those things came together to give the bad guys this wonderful experience. Right. So who would like to see it in action? Okay. Yes. Now this is the hard bit because now I've got to switch. Right. So I've now got to switch to that one, I think. Yeah. Right. So I have here. Right. So another thing about Log4j, and this is another good takeaway from Log4j, is it also showed us that it's not as simple as saying it's this version or this version. There are actually more complexities to the situation. Anyway, so what I have here is an app that is my hacking app. So I have a real application running in the back here, which I've managed to break, so it doesn't actually do what I thought it should do, as in I'm going to say things like buy milk. Right, it should say buy milk here. Right, now if you look, you'll see in that black box, let's see if I can make it a bit bigger. It's going to be fun. Right, it says add to do. Right, that's the sort of, I've taken a lot of the login rubbish out. Right, now the reason you can see all this stuff here about versions of Java and all this stuff is because I wrote the tool because I wanted to explore all the various combinations, right? And there's actually like 500,000 different combinations of stuff to try because I wanted to be clear I understood what the rules were. Right. So in this case, I'm using this blue button here. It says that I'm using JDK 8, right? And I'm using Log4j 2.81, right? Now, I can switch around them and I get different effects depending on which one I'm running. But we'll use this one because it's fun. Right, and then I've got this list of things, right? So look, let's pick the obvious one. Sys Java, let's pick that one there. Stick it into the app. Now I'm just putting this into the command, into the form on the app. It could come in any form. Any way of it being logged is all that's going to trigger this. So I mean, may not do this, but they could do. So I do that, and it runs. And now I've got here, you can just about see it in the red. Can you see that? Is that visible? Oh. You can now see it says whatever version of Java I was running, 8U102, which is what I picked, right? That's the easy one. Okay. So the bad guys would do that, tells them what version they've got. Then they might pick this one because, I'd like to know what you've got on your class path. Now these things are all running in Docker containers, so it's not super exciting. Okay. I mean, you get the gist. Okay. So the classic you would have seen would have been one like this. Okay. So this is an LDAP call. It makes a call to a server called ldap.dev on port 1389, and it passes in A, which actually isn't valid LDAP syntax, but that doesn't matter because the server's been compromised. So I do that, and and what do I get? I get this weird thing. Thank you for your data. Right, now if you look at what the LDAP console's been going through, right, it gets that key A, and it knows that actually it's got an object, and I'll show you the code. It's got an object called A. It's got an object that it needs to give back. So it gives back a Java object. And the Java object ends up being a string, which says, hey, give me the version, like Java, sys Java version. So I give that back. My app says, thank you very much. The substitution gets replayed. And now I've the information comes back, right? It's not coming out here, is it? It's not coming out in the log for the application. It's coming out in my LDAP log, right? And so that gives me back a version number, right? Key version, blah blah blah, and so on. I ask for all sorts of things, right? Whatever it is I want to ask, and then I go, hey, okay, I'll return some nice little innocuous thing, right? So maybe they wouldn't do this. They might return this with buy milk, my log would never spot that that had happened, right? Now this particular thing here, where are we? This particular one here is what's called a gadget chain. And we'll go through these in more detail in a minute, but this is a gadget chain. And the gadget chain in this case doesn't want to do anything more than with whatever you've got installed in your system. But there is a more exciting version, which is this next one, which I'm going to run. Says he is a demo, so here we go. Oh, okay. So this will return all sorts of stuff. This is arbitrary code, right? So let me show you the code. Well, I'll show you the related code, because I have another demo, which is the one that I was going to show you if you wanted to play around, but I'll talk about it now. I don't know if you can see that. Is that readable? There's an object, so it's called external object. That's for my case. It doesn't matter. It implements this object factory, and it has a particular method structure. And then any code that it's in here will get run on the application server. And I can create code, right? Because tucked away in here, if I can find it, is some more stuff. But the best thing is, if you can see at this bottom, there's this thing that says reference. Right? So a reference object is a nice little handy thing that tells you not just the code to run, which is that next package name, external object, but also, or the factory state the same, but also a factory location, which says, here's the URL to go to get the code. So that means that in this method here, it means that any code in there, any code on my server that's reachable when I create this can be loaded onto the remote server. And all that matters is the Java version. Right? So I don't need to I don't need to worry about what you've got installed, because in this is, and this is obviously the worst case, in this case, if you're susceptible to this, I can run whatever I want. Right? And the demos and things which if you're interested in playing with, you can do that. You can basically do this, because this code is available. It's the Sly server stuff. So it's trivial. I don't have to do anything. I don't have to know about Java serialization. I just have to write some Java code. Registering this is easy, because there's code in there that it's just J and DI. So I can register the code that I want to load. There's an interceptor server in here. The LDAP server here is written in Java 2. So that was nice, a little bit hackery, and I can then take whatever comes in on the URL / whatever and turn it into some object that I want to send back. Easy. And you would never notice. Cool. Right, let's go back. Okay. You've seen that in action. Was that what you expected? That's trivial, right? Now, bearing in mind that the data that you log came from, I put it on the, I put it on the form, but we could look at the fact that it could be anywhere, anything that you log. But the framework logged, if you're using, a framework is using the wrong version of Log4j. It can be data that got inserted into a database, and then you log some update or some action on that record, and you record it. Doesn't matter where the data came from. It just gets to the point where that happens. And once that happens, you now trigger Log4j to make a call out to some server, have a conversation, returns the data, invisible. And now you can see why it's that bad, right? So you can see all these sorts of things. I mean, I didn't show all of them, but you get the thing, right? I can get at your environmental variables. I can transmit it out. Even if I can't do an RCE, maybe because depending on what version of Java and what version of Log4j you've got, you may not be able to get that full amount of control. But if I can get some data out, that's cool. If I can get it into your log, that can help, because your logs can be compromised. So all these just help me, one way or the other, compromise your system, because I can get some data out, right? And then the gadget chain, gadget chains are literally a sequence of serialized Java objects that are used to subvert your system. And if you want to know about Java serialization, we'll do that some other time, because it takes just as long, right? Okay. Yeah. So gadget chains. Oh yeah, gadget chains aren't necessarily complicated, though they always seem to have that reputation. It can just be set of objects, right? I've got gadget in there as well. So you can do all sorts of stuff, right? And depending on what circumstances you get, you know. So the reason I wanted to bring this up is, as I said, is we have a very black and white association with vulnerabilities. We go, oh, that's for me, or it's not for me. And the problem is that that's never quite true, because it might be true right now that it's not going to affect you, based on some set of knowledge that you've got, but that can change tomorrow because when a dependency changes, or somebody changes your gateway config, anything can happen, right? So the fact you're not vulnerable now doesn't mean you won't be in the future, right? There are, it turned out there were some older versions of Log4j that didn't have any of these problems because they had a bug in it, and the bug protected them, right? Yeah. Okay. Yes, so here, another one, cn equals boom. I have create an object array. Not real code, of course, but what happens if the object array that I create is basically an array of int max, in maxes, right? Depending where you're running, you might be in a constrained container. I may be able to bring your system down, make it go out of memory every time. And if I hack the serialization form so that it's not really, I couldn't really instantiate it, right? Because if you think what happens is your objects can gets turned to serialized data, the serialized data then gets sent across and it gets turned back into real Java objects. I can subvert that to ensure that that int max could go on forever, and then your system would then definitely crash, however big it was. Right. So imagine that. So not only can I steal your data without you knowing, if I really feel like it, I can crash the systems. Right. And all you'll have in your log, well, I don't know what you'd have in your log, because maybe it never got recorded because I crashed it before log4j completed. Right. Yeah. And as I said, like the RC, you can't really see that, can you? Shouldn't do red on black. That's yeah. Yeah, and this reference object thing is a killer. It's in there because way, way back in the old days of Java, there was this idea that wouldn't it be good to have a code server that you could just download code from when you had a big cluster of machines and you were sending data backwards and forwards. It's like, well, where do I put the classes? Well, we'll have a server for putting all the binaries on. And here's a reference for how to get them, right? But it got exploited because we built a feature that was very good for us developers, but we didn't put the thought process into it, and it got exploited. Right? Cool. Yeah, there we go. Yeah. So with that and this implements thing, under the right circumstances, I have complete control of your system. Oh yeah, so obviously moving up to different versions of Java is good, but don't think that just because you've moved to the latest Java 17 that you're safe, right? And just because you aren't using Log4j doesn't mean that it isn't being used. Right? That's quite feasible for me to set up have a situation where the dependencies I'm relying on are using older versions of Log4j. Right. I did all that sort of stuff, yes. Did all that. Yeah. There are a couple of, well, there's 3 system properties around Log4j, and depending on what situation you're in, they can be enabled because it's an older version of Java, or they can be disabled because it's a newer version. But just because they're disabled by default doesn't mean that you're not running some code that enables them, because if you have any situation where you're launching JVMs and that config can get to, then of course those JVMs can be changed to run, to turn a property on. You have to get this in your head that it's not just this instance. You have to think about the bigger picture when, well, what happens if this and what happens in this, right? All these things will happen. So one of the biggest takeaways is that you have to start thinking about defense in depth. About, I know it probably wouldn't happen, but what happens if it did? How would we know? Okay. Right. So it's deadly, but it's a wake-up call because an example of what's really happening. And then we had Spring Shell and what's the other one? The other, yeah, well, the 2 Spring ones. And I said, now there's another one, right? But there's a whole bunch of takeaways here. Right? These things being these vulnerabilities are being weaponized and in fact being created to get at your systems. You've got to deal with that, right? And if you don't patch now, right, you're vulnerable. Even if you don't think you are, you will be vulnerable because there's always a way in. You've got to start looking at how you build processes around your software development. That means that you're always updating your software as quickly as you can, as automatically as you can, because you have 0 time, right? One can come out tomorrow. One probably will come out tomorrow, okay? And you're going to read it and go, oh my God, what can we do about that? Because there are always fundamental problems that come up, right? And then you're going to scramble like we did for Log4j. Anything else that I should point out? Number 4, one of the other side effects of Log4j, which were actually good, was to see how often people came up and said, we've written a special scanner to find Log4j. Right? If you see that, run away. If you see people saying, I have a tool that can fix Log4j forever for you, run away. Right? Because if they've written extras to find Log4j, that means their scanning software is not that good, right? And if they say we have a solution for everything, then you can believe me, you can say that's not true either. You have to, again, as developers, you need to get involved in the selection process for the software you use for vulnerability scanning, because your IT guys won't understand all the variations of where Java code can be. It isn't just in your dependencies. It's in fat jars, right? It's in Java modules. It's like, where are the places that Java code could be? And could those scanners find them? So you have to start getting connected to those things, because you need to be able to make sure that they're going to find the stuff and not just get a tick to say we have a scanner. Right? What have we got? Yeah, malicious intent to corrupt software projects is growing. It is. I cannot stress it enough. It is. Node is getting it in reams because it's really easy. But believe me, these guys are going to go where they can because of what they're trying to achieve. Right? And we talked about how this is going to get some government attention. Okay? And we'll talk about that in a minute. And number 8, developers often assume it's not their problem. So I'm really glad that you're in this room listening, and hopefully you'll go away and going, I'm not sure what to do, but I know I need to do something. Right. So I would suggest, I'm trying to think what time it is it's 20 to 3. So how about you take a 5-10 minute break? Well, I'm going to say about an hour on this, and then we'll have lots of time for questions. So I'm going to take you through the high level basics, right? So I'm not going to educate you on the specifics because we just don't have time. And a lot of it is education's out there for you on how to create safer software. You just got to go find it and start reading it. So it's there. Just like there are people out there who know how to penetrate the systems, they have been very kind over the years and have created all the documentation you need to how to think about designing software. Right? But there are all sorts of ways of thinking about it. And so I want to lay it out for you slightly differently you might see elsewhere. I want to talk like this, because actually this helps us think about the principles. So we're going to talk about prevention. How do you stop the bad guys getting into the system in the first place? What should you have in place? Then, because it is inevitable that at some point somebody will get into some part of your system, how would you know? How do we think about detecting that? And then, how do you think about setting up your system so that when the inevitable happens, the damage is reduced? So mitigation. So it's mitigation ahead of the fact, if you see what I mean, because obviously you can't prevent them getting into the system if they get into your system. But that's basically going to lay it out. I got like 10 points, and we'll go all over the place with this stuff, right? But it's start exercising your thoughts about how you think about software creation. Now, something else that Log4Shell has shown us is we are pretty poor at the one thing that would reduce your exposure, and that's managing your dependencies. So I could go to this Sonatype, because Sonatype manages Maven Central. That means we get to see what the downloads are like. And so we track this stuff, and occasionally we'll put up some website to publish exactly what's going on. So whatever this was, not that long ago though, total downloads since December 10th and whatever it was, 28 million. 42% were for versions of Log4j that were vulnerable. What we saw happen was just after the 10th of December, when the problem came out, there was a big spike in people moving to the latest version, which is good. But only 60% of the downloads got fixed. There's another 40%, and it's still 30, 40%, depending on what day you go and have a look, of people downloading old versions of software. Right? Remember, this is Maven Central, so this is where people go directly. This is developers doing builds. It's build systems doing builds. It's people who don't have a cache. 42% of software out there. Just think about that. What does that imply? Well, it implies there must be some people who just didn't get the message. But more likely, there are people out there who are either going, doesn't appeal to it, doesn't apply to us, or, well, we can't do it because our software configuration means if we update this, things will break. Right? But the most likely is that many people don't understand how dependencies work, and they don't understand that they're even pulling this in. Because if you think about when you do a build, we do, Maven compile for the first time, and you've changed the dependency, you get stuff, right? And because dependencies bring in dependencies. So the chances are a good chunk of this are people creating software who do not understand how dependencies work or don't care. But remember in mind that 90% of the software that makes up your application, you didn't write. 90% of the open source software is from somebody else. And these are the guys who are providing the software that you're consuming. And the chances are that there are open source projects out there that didn't get the message, don't know what to do, and are still using old versions of Log4j. And if you don't think that by downloading one of those, just because you've got the latest version of Log4j in your dependency POM, that you're not vulnerable, you don't know how dependencies work. Because it's possible. You need to go read how Maven dependency works, and what the options are, and what people can do to override your settings, and vice versa. So, if we were to fix this problem, we would be so much closer to being safer. Because at least when a new vulnerability was announced, we could all press the button and get updated very quickly, and that would just make life better for everybody. So it's like the number one thing that you could do tomorrow is go have a look at how your system builds, go check out the dependencies, do a deep scan, just look at the dependency list and see if you can see whether you've got an old version of Log4j, and start thinking about how you would prove to yourself whether or not that was a true case, because these are Maven dependencies being downloaded. Sometimes these things then get repackaged, and the output that you consume may not even have a dependency relationship because they may have put it in a fat jar. Right? That happens, and we've seen people even take the vulnerable classes out of Log4j and embed them in other classes. Right? But anyway, number one, it would be go figure out whether you're one of these people, and if so, fix it. Right. Yes, I think I've just said a lot of this, but you're pressured. You go, I need to get something fixed. So you do the Stack Overflow scan stuff, find it, go find the latest version of Maven, stick it in. You may go talk to your IT guys and go, look, I need this version of this thing, and there's some, maybe they go check the policy, the license, people check licenses, right, but that's about it, and that gets signed off, and you're in, right? Something that was in your system is now in. You have a dependency, as I keep saying, you have a dependency on the software, the features it provides you, but on the character of the people this is coming from. Okay. So you need to look at the tools you use. What does Maven do? Do you know that Maven's got dependency plugins that can check things for you? Do you know that you can apply rules? Right. Do you know that there are other tools? Do you know what Dependabot can do for you? How far is Dependabot able to find these problems? There are thousands of tools out there that scan. Just pick two. One you could run your command line, one you could run your GitHub repo. There's loads of them, right? But the question is, do you know what they do and how they do it, and whether that would be a right answer or not? This is now your responsibility, because you're selecting the software. Nobody else is selecting the software. You're selecting the software. Right. Yeah. And would either of those be able to tell you that this particular version of bad food jar is knocking around in a fat jar? That package has been included? Would you know? I think you'll find the answer will be no on both of those, but you know, you need to go check. Right. So number one, your dependencies are your Achilles heel. You have to be much better at choosing them. Right? You need to look at all the tools that are out there and find the tools that will give you the right answers. But before that, you have got to start investing some time to think about what the right answer looks like. Right? How do I know? Because the next time you pull in an extra dependency, you might be pulling in some bad guys. Right? And anyway, every time you add a new dependency, that adds in extra dependencies. So it's not just, well, I'm putting in one bad guy. I could be putting in all sorts of things. And it doesn't have to be bad guys immediately. It could just be that the open source project that you're consuming hasn't got much of an idea of how to do software development properly. Because, well, it's open source. You get what you get. You know what open source licenses are like, yeah? Yeah. So there's a whole bunch of stuff there, yeah. And then don't just stop at the Java code that's in your application. Many of us, you know, if we're writing full stack stuff, there'll be some JavaScript in there, some CSS and stuff like that. You know you can get vulnerabilities in CSS? Do you know that, you know, you get loads of vulnerabilities in JavaScript? We're very good at taking some JavaScript. We might do, oh, I need something. I need to get that in the browser. And, you know, okay, so I'll npm install it, and then I'll script it, you know, pull it out and stick it in my project, and I'll rename the JavaScript file because it's too long, or I don't like it, or it's got version number in, and it becomes a thing. And suddenly, all tracking is gone because nobody can track JavaScript code that way when you do those things. And so suddenly you find you're serving up JavaScript code that very quickly gets old and people find vulnerabilities and nobody will ever notice until it's too late, right? So you need to think about all the software you've got, right? And that extends to like plugins in build servers and stuff like that. There's a whole place where you consume software. What are your rules? Not what does your IT organization say about, well, it's in policy, you know. It's like, no, what does this thing give you? What does it bring in? What else does it bring? Go look at the open source projects and start examining, right? Oh, and then the last thing is, in this space, is when you're looking, you think about where people are reporting vulnerabilities, who's reporting them? Where's the data going? How good is the data? Now, there's a main CVE database which eventually everything ends up in, but everybody who's got who have got security teams, I mean, Sonatype's got one, Snick's got one, you name it, everybody's got a security team, they gather data. Now, where does that data go? And just the tools that you use, does it use one of those, two of those, 10 of those, none of them? Right? Because if the data, the tools you use to report whether you've got vulnerabilities are using public data, and the vulnerability has been found by somebody, you know, who's not quick at reporting, well, they can publish it and tell the world, but that number doesn't appear in your database, so you don't realize you've got the problem, you've got it, right? And bearing in mind the exploits time between publication and exploit is negative. Every time, every place in the process where that information could be delayed can get to you. So again, you need to get involved in what your IT companies are making, your IT guys are making decisions over, as in terms of vulnerability database scans. You know, it's like, be involved because you understand what the right answer is. Now, you may not know it now, but you are fully qualified as Java developers to understand about dependencies, understand where Java code goes, understand what sort of tools you need to find the Java in the right places. Right. And we talked about that earlier, and we talked about all this, right? All this things that they can do. This is also becoming part of your remit. This is part of your decision process. When you go to Stack Overflow and you look at it and you go, okay, there are, again, instances of people posting stuff to Stack Overflow that have deliberately typo squatted names in them that you cut and paste because somebody says that's the best thing to do, and it's just a scam. It's just a, you know, it's just a little pot to grab your attention. You take that typo script name, you plug it in, all works well. Thank you very much. You've now given them away in. That's how sophisticated they are. You have to go, do I trust the people who are telling me things on Stack Overflow? Well, you go prove it yourself, right? And it comes back to how we choose open source. How many people here have downloaded something from the internet? We all download them, okay. So how many, let's talk about software rather than maybe other things, right? So you've downloaded software. How many of you who've downloaded software have checked the license of the software? Yes? Okay. Right, so then what about the license of the dependencies of the thing that you've downloaded? Maybe one or two. Maybe if you've got a tool. And what about the dependencies of the dependency? No, you get it? How many, right? And then it's like, well, we don't, right? We rely on some other tool that the IT guys do, because that's what they do, and they have a big cache, and they stuff, you can have stuff out of here, and you assume that they've done all the due diligence for you. Well, they haven't. They've just got a machine that says we'll allow GPL licenses or MIT licenses or whatever, and then maybe they put some more effort into going, well, well, actually, what could they do? You're going to say, there's this project. Your IT guys aren't qualified to run an open source project and tell you whether that open source project is good, right? We choose the open source software for the features it gives us without thought about consequence to having that in. We don't look at the extra features that we get that we may not use, like for instance, Log4j pulling in JMDI and then giving them LDAP, which then gave them a bunch of other stuff, right? That wasn't the intent. They just wanted the JMDI feature. They pulled the other stuff in. So again, you have to start making trade-offs going, do I get what I want? What else do I get? Do I trust the people who are giving me this? Whereas trust doesn't mean, trust. Trust means, are they doing the right things? Do I feel that in circumstances where problems will occur, they would be there to help? Log4j has shown us how much we rely on open source. It's also shown us how much we assume that the open source projects will respond, and that if you have a problem, they will fix it, right? Because, well, they don't have to, unless you have a support contract with them, in which case it's not open source. But if it's an open source project and you turn up and go, can you fix this vulnerability? Well, it might be some guy that's, working nights and he's just produced some open source software because he wanted to. He doesn't have to do anything else for you, right? And you'd be surprised at how many large companies have been hitting open source people on the head because they haven't responded in the way that the business expected, though there was never any contract. And we're seeing open source projects start to disappear because individuals go, I'm not doing this, I'm taking my software back, right? So we have this whole dynamic, but ultimately when it comes down to you as an open source consumer, is you've got to go and look at the open source project and start making some assessments as to their hygiene, all the things that they do, about your views of, could it be compromised? Do you feel that if things went wrong they could help and they would fix things? There's a whole bunch. Again, it's far too deep for this for now, but you can see there are some things that you could imagine wanting to do. Right. Like this lot. Do they have vulnerability reporting process? How many, do you check that? You go to an open source project and you read the instructions or you install it. Do they have a reporting process? Do they say things like, if you find a problem in our code, don't report it, don't raise an issue, contact this email address or something like that? Because if they don't, and they just, if they go, it's to create an issue, well, that's not good, is it? Because everybody can see it, right? Do they have their own security tools? Do they use them? Safe installation process. This isn't just about dependencies, this is across the board. How often have you seen bash, pipe, sudo, curl, and some script, right? And we cut and paste that. Somebody goes, oh yeah, you can install my script. Cut and paste, right? Bash, sudo, blah, blah, blah. Okay, thank you. This script now has full access to my machine. I gave it to them. Does whatever it does. Have you ever taken it apart? No, because you want whatever it's offering. See? What else? Ability to provide updates, which I think I said was how amenable are they to updating, but also actually have a look at how often they do updates, because that will tell you about whether you can get them to fix things, but it also tells you, if you come back later, some sense about their activity, and also it can be a sense of being compromised. As I said, I think way back, beginning of this talk, was a classic sign for compromised projects is they start releasing very fast, because they're trying to get stuff out there as quickly as possible before they get found out. Excuse me. Right, build process. You can have a look, find out who can trigger their build. Is it GitHub action? Excuse me. Oh. So is it a GitHub action? Is it a Jenkins server? Who can trigger it? You need to go have a look, because you're assessing the value of this open source project. Quality. There's a thing knocking around called MTTU, which is about release process and not only about their own release process, but also their consumption of downstream dependencies. It's another topic, but basically there are guidelines that you can use, and I expect this stuff will end up being, eventually I expect a lot of this stuff will get parameterized, and we'll start to see people making it available because this will start to become important information, and you don't want to do it yourself if you can get these rules, right? Unusual patterns, I said, and then new committers. How many committers on the project? You can find no projects with thousands of committers. Some guy just turns up with a fix and it's done, right? If it's one person, that's not necessarily bad, but if new people turn up, you know, it's like, well, okay, there's been 20 people here for 10 years, and then 5 new people turn up. Is that a sign the project's been compromised? Is there a sign that the project is asking for help? It's all these sort of things that give you sense about whether the people who are producing the software that you're consuming are doing the right thing. Right? And of course, there's no science here other than your assessment of those people, which you've not been doing before, but now you need to start thinking about if they worked for you or they worked with you, what do you think? Right. So there are things that we do, let alone what other people do, that aren't necessarily the best actions. So even if you don't have vulnerabilities, right, bad guys still get in because we help them. And one of the classics is this one. Has anybody ever written something like this? Yeah. I mean, you can all put your hands. I mean, yeah. Why do we do this? Well, it normally goes like, I have a server I want to talk to, but it's self-signed. So I'll just do this, and I'll just write a trust manager because I went on to Google, and Google said, if you do this, all your worries go away. And it's ever so easy to do because it's just an interface with 2 methods that you return true, right? It's funny. I've done it, you've done it, we all do this because it's just easy. And that's another thing I want you to start thinking about. Just because it's easy for you makes it easy for the bad guys, right? Turning off security, which is basically what this is a bad thing, but we do it all over the time. I mean, you can just see people Googling for, how do I turn off certificate checking with curl or whatever, because I want to download something, and and you get this all the time. We do this all the time, right? Okay. So, it's funny, but I did a GitHub search for implements trust manager. Oops. Which was not that long ago. This is updated. So, 144,000 hits in GitHub of implements trust manager. Okay, and you go, wow, okay. And then when you start taking it apart, you get words like this. You get over-trusting trust provider, the all-trusting security manager plugin, trust all server wrapping trust manager, always valid trust manager. This is in GitHub. These are real classes that people have created to work around this problem because they all do similar things, and they are features. One of the worst things we can do to help the bad guys is to do things like this, which are make our life easy because we can't be bothered to fix the problem. We just fix it the quick and easy way, and we then open the hole for them. And then that mentality then turns into people creating features, and then you find documentation that says, yeah, if you want to turn off security checking, just do this. And it's in the GitHub projects that we consume. Hence, you need to go look at their attitudes because you don't want this stuff. You might want something, but you don't want all this stuff in there, do you? Because bearing in mind, even if you don't use it, it's code available for the bad guys to execute, which you don't want either. So, don't pull in code you don't need. Have a really good look at the code you pull in. Right? If you don't need it, get rid of it. How many here use Docker containers? Yeah, most of you. Yeah, okay, it's the mainstream thing now. How many people build your Docker container from scratch? Look, actually hands go up. I asked that and people going, okay. So most people, when building a Docker container, will pick a base image, which is, I don't know, Ubuntu or Alpine or something like that. And you may have a corporate base image, right? But inside all that is a whole bunch of tools that you don't need. And every single exe that's in your system, in your Docker container, every executable piece of code could be found and reached by an RCE like the log4j one. Right? Because log4j, I showed you running Java code, but of course if I'm running Java code, I can create a process. I can drive a process. And if I can drive a process, I can effectively run anything that's in your container. Right? So everything that was in scope of the application that you've created, its environment, that isn't there specifically for it to run, has to go. Every single one that is a vector. Right? So you can't use random base, or you can't use big fat images because it's easy. You have to start looking at and there are tools. There are Quarkus has got them, and Google have created other tools, and there are various tools out there that you can take the Java application and basically take an image and there's nothing else. Or you can do it by hand, you can take a scratch image, or you could go and have a look at your corporate base image and go, why do I have all this stuff? And take it out. Because every single one of those is a vector in, right? Everything. And it'll make your image lighter, which is good, but it'll make it safer. Right? Nothing that you don't use. Yeah, I think I've said most of this, but it's not only about the tools, it's about the features, and start making some decisions about whether you think you want to have that dependency to give you that string formatting function, or whether you're just going to write one yourself. Right? You can fork code, you can borrow it, and yes, you may have to maintain it, but it may be less of a risk to do something yourself than to pull in this big chain of stuff you have to worry about. Right? But we don't do that often. Quite often we'll go, oh, it's complicated. I want to do I don't know, charter hex printer. What can I do? That's hard. Oh, I'll find one. And they're the things that pull in. In fact, paradoxically, a lot of the little holes that we get come from those developer utilities, because they're done by developers for developers, and we don't really think they're part of the whole thing. They're developer tools, right? So I don't care so much, because they're never going to get hacked. But it is time for you to look at the features and to make real strong decisions about whether you're getting value, right? And if you do need this stuff, as an aside, if you are going to take any of this stuff in, have a really good think about how you compartmentalize it. Your software architecture should look at these things and go, are they fundamental, or is there a possibility that I might want to replace them? And anywhere you go, well, I might want to replace them, you put a bit more engineering in and you start creating architectural separation, right? We're not very good at that. We're not very good at, we take all the stuff that's good, that's easy. So you might have, you might have a whole bunch of Java code that's talking to a database, and you get stores and containers and all sorts of objects, and they get created for you, and you use them directly. And a classic is you might have an ORM thing where you have an ORM store where you can pull objects out, give you an ID, get an object, nothing wrong with that, except for you give the store away and it floats around your application, anybody can touch it. Right? And then that's not a very good secure thing, but it also means it's really hard to replace. Whereas if you had a little interface that said, here's the interface where I can do the things I want to do, and under the covers that delegates to the store, that's a much better structure, right? And you're probably thinking about those lines anyway, but another reason for doing it now is because it compartmentalizes the risk and gives you the opportunity to maybe replace those things if you really have to. Your use of dependencies isn't just the fact that you've put it on the command line, or you've put it in dependency list. It's actually your interaction with that code that also has to be compartmentalized, right? Don't have it everywhere unless you really have to. Right. Well, we did that one, didn't we? Yeah, and I think I've talked about this one. Automatic vulnerability patching. You just don't have time. I just cannot stress you the what's going on out there, right? There's a nice little list. This is public, let alone what's on the dark web. The tools out there that people have developed and are developing that allow you to find bugs and get paid for it, right? So automate. And then there's all this stuff, which I touched on, this supply chain malarkey. This obviously starts to come down to the way that we think about how we build software and how we consume software, because all this thought process about whether stuff is good or bad is going to become formalized, because it has to. It's the only way we can start to manage the software supply chain. Did all that, did all that, did all that. Yeah. So you don't, again, it's this sort of like, you need to get ahead of this, right? Because even if you work for a company that doesn't sell to the US government, you might be selling to the French government, and they may start doing the same thing because all the governments are in the same boat. And even if you don't do that, you can be selling your software to somebody else who's selling to somebody else who eventually sells to a government. And as soon as that starts to become clear, the guy at the top of the chain is going to scream and shout and say, well, I can't sell 2025, right? 2025 is all you've got, theoretically, before these rules start to be something that you have to start looking at. And so I think the point really is that you need to start thinking about this now, regardless of this, right? This is like first reaction, but it's a reasonable reaction to start saying the way you produce software, the audit trails, those sorts of processes are incredibly important because they help us manage our risk, and they're going to happen, and they're going to become part of our lives, right? And so why not get ahead of that now, right? It isn't enormously complicated to start making sure that you can apply your vulnerabilities automatically, that you can have a build process that's one button and doesn't require lots of intervention by human beings, right? And that it doesn't take too long to do. You start doing those sorts of things and you're halfway there. And then you start looking at the SBOM activities. And SBOMs, there are tools appearing all the time now which will help you produce that the bill of materials. That will evolve over time as we figure out what we really need to put in it. But you could do that now. You could start plugging those into your Jenkins servers. I think Docker's got one. Man, they're just turning up, right? Because it's easy to produce a bill of materials. Right, what else we got less? Yes, number 6. I've told you, you've come here, and I've told you all about what the bad guys do, when I've told you a fraction of what they do, right? I hope I impressed upon you that they are very inventive. One of the best ways to learn how that works is to try it yourself. And there are lots of examples out there where people have put systems, not necessarily Java stuff, but that doesn't matter, right? There are capture the flag projects. There are the OWASP guys have a whole bunch of stuff. If you start to learn how people attack your systems, you will start to think better about how to design it so that you don't get attacked, right? You know, this is prevent it happening by understanding how you get attacked, right? It's like, you know, if you were wandering around a foreign city, right, you might just to put some thought in as to where you don't really want to go. But we tend not to do that with software consumption. We just wander around and just, you know, whatever happens, right? But it's you starting to think about these things, and this is one of the best ways of doing it, right? And the reason that you need to start doing this is that there are other people doing it already, and it's published. Every time somebody publishes, hey, I did some hacking on Docker or whatever, it's another piece of ammunition for the bad guys, right? I would say follow the cybersecurity topic on Twitter. It's not, I mean, it's regular, few posts a day, but all sorts of cool stuff comes through that will help you understand the space more. And lots of times you'll get through that somebody says, oh, I did this. And you can find a GitHub repo that tells you how to try something. And you just try it out and see what happens, right? You start getting your head round sometimes how easy these things are. Because I would say, as well as when we talk about vulnerabilities, they're being exploit first, you can bet that pretty much every vulnerability nowadays, when it gets published, before it gets fixed, there will be a publish and there will be a POC, a proof of concept. So there will be direct, easy to use instructions on how to exploit you. And sometimes they're based on what these guys produce inadvertently, but actually you just need to go see how easy this is. Some of this stuff is trivial. Like the log4j1, fairly trivial, the Spring Shell stuff, there were 2 POCs and they were instantly usable. Right, very easy to use. Right, there are some other behavior changes that you could do. Is don't share information with each other in, silly ways. We all do this. We all have silly passwords. You are, as a human being, as a developer, are just as much a target for the bad guys as the software that you're writing. Because if you don't have good security hygiene, then they can compromise you. And I don't mean compromising your system. I mean, you just will go, oh, I reuse passwords. Or I'm always talking on Facebook about stuff that I shouldn't be. I talk about what my project name is. I talk about the people I work with. I talk about my relationship with my bosses. Anything that's like that, if your relationship with your boss is not very good, that can be used against you. I mean, again, more than I can do here, but your personal relationship with people can be exploited, because bear in mind, they're doing this, one subset of this is to compromise you because you work in part of a supply chain, right? So these little habits that we have as developers of, always having root password and stuff like that, you've got to start looking at it differently and understand that it's maybe a convenience for your team, but it's a weakness. Okay. Understanding the tools you use is probably another big thing, because we are so busy, we tend not to do that. So how easy is it if you inadvertently committed a password or an API key to GitHub, how easy is it to remove it? Can you do that? Can you just delete it? Easy? Hard? Who thinks it's easy to delete miscommitted? Okay. So you all realize, good, you all realize that actually taking something out of Git is just by deleting it is not a good idea. Yeah? Okay. Well, look, another GitHub search. Okay. You can do this. Go to GitHub, search for issues with removed passwords. Right? 460,000 people. Okay, I'm sure some of them will be rejected as, well, you can't do that. But you understand, right? This happens because people use tools they don't know how to use. They just use them at face level. So again, let me put on your list of more work is that the tools that you use, you need to be much better at being expert. Sounds like you're okay with Git, but I'm sure that other tools you use, and one of the classic complaints that you get when systems get compromised is that IT guys, developers go, oh, the tool didn't behave the way I thought it should do, because they didn't understand, they just wanted one feature, and they got all this extra stuff, and they used it wrong. Right. How we think about our application design is also important, and authentication being like number one. We're very good, because it's convenient, of having a model of no authority to everything, right? We tend not to, unless people hit you over the head with a big stick, think about it from a use case point of view. We're very good at going simple user, power user, admin, root, and this assumption that you can do this onion ring thing, right? So all that means is that if you've got more power than I have, and you log into your system and there's a vulnerability around that would allow me to steal your credentials, I can now become you somewhere else, And believe me, that's fairly trivial. And now I have not only the powers to do maybe a little bit more than that before, I have got all your other powers. I can do whatever I want because you gave them to me, right? You may never do these things, but you had the capability. You had extra features that you didn't need, but it was just easier, right? So you have to take a different architectural view. I know many people do, but I want to reinforce it to say you line your authentication, your authorities up with your use cases, and you take another good look at your use cases, right? If you have a muddled approach to security, the bad guys will find it. In fact, it's one of the classic ways in. One of the you'll find is pen testers will do is that they will look at all the APIs that you've got and they will work out how far they can get without needing authentication. And then they'll try and take authentication from one place and apply it to the other, right? Because bear in mind, I've got a browser, I'm talking to your API, or you have an API, I've got some code, right? I talk to you, I get something back. What happens if I take that authority and I try a different API, right? And that's what they'll do. And if you have situations, I mean, you know, silly things like you go, well, if I've got this piece of data, therefore I'm going to go this way, and if I've got this piece of data, I'll go down this way. Right? The bad guys will try it out and go, what happens if you have both bits of data? Can I force you to do things you weren't expecting? And that's what it's all about, is looking at your muddled code, your muddled thinking, and you tend to do things like muddle updates with ads because quite often the form that you present is the same, and the only difference is that one you already know what the ID is, and the other one you haven't created it yet. But it's nice to reuse that software, right? And if you do it in a bad way, bad things happen. Because the bad guys are going to probe every API that you've got, even the ones that you don't want them to use. If you've got test endpoints, right, another classic, this is where you find APIs have been created by the developers for the test team, and those APIs don't have authentication because they're just for testing, and it gets in the way. And those APIs are never meant to leave the building, so to speak, but they do, they get discovered. And when that happens, the bad guys have now got unauthenticated ways in. So they're cool. But they'll do this. They will try all of these ways to prod your system, right? And I'll bet you that if you were to take some of these and apply it to the framework that you've got, some of the combinations won't even show up in the logs. Because some of them just have an automatic don't be stupid return and never gets logged. Right? That's a cool sign. Right? So you can see the bad guys know the structure of APIs because any structure that you can think of, because it's REST. So you've already told them that you do this to add one and this to get one. Right? So they can already work around their API. And this is all programmatic. These are bots that just do this. There's no human beings involved because it's programmatic and it's easy to guess. Right? It's called fuzzing. And just like all the other stuff I've been talking about, there are sophisticated tools and sophisticated people. OWASP have got some, everybody else has got them, for fuzzing. Take your API and try it. So what happens if, so I've got user 1 or user 2. What happens if I do user -1? What do I get? Does it break your system? Does it take your code through routes you weren't expecting? They're not supposed to do that. Why are the developers, why are users doing that? Can I do SQL injection? What happens if I put magic numbers in, of which there are many? And believe me, all this information about what will break you, what's called bad words, is shared and published because it's common, right? And this is automatic. Boom, 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 boom. Right. There we go. So automatic protocol, they'll probe your system. You turn a system on AWS. If it's got a public IP, it'll be probed in a few seconds, and then there'll be a bigger probe, and then so that'll work out what you've got, and then fully crafted attacks happen. No human beings involved, just happens. And that idea of You know, you can't have a default root password, because if it's got a public IP address, it will be compromised like that. But people still do that. But everything is out there. Tooling, approaches. When I say fuzzing, it's not just APIs, it's binary formats, XML. The tools will try to stress your system to find the breaks and the cracks. And it is fully automatic and very sophisticated. Something else to put on your list to go learn. Right. Number 7, secrets escape. Secrets do escape. We are very good at misleading them. Book them into GitHub. You have to think about what the consequences are if the secret escapes. So you have to have remediation processes, compartmentalization. You have to have mitigation strategies that says, okay, what happens if this escapes? So obviously the first thing is to reduce the effectiveness, you know, and use the API tokens and things like that, you know, down to the least that it needs to have to do that business. Because if all that it comes down to is you have to flow more data to a client to get things to happen, but you're safer, that's a better trade-off than saying, well, it's much easier if I just go, here's a key that lets you do everything, right? Look, you can Google for this. This is yet another set of pen testing instructions for how to break it. All sorts of ways of getting in. So when we say gets out, sometimes it gets out in ways that doesn't mean they actually can read the numbers, so to speak, but they can just take an authentication environment. I've authenticated. I have this set up, which is now valid. Now the question is, can I take that to a different place and try it with different configuration, right? So if I authenticate with you, your server, and you go, yeah, here's token, you go, thank you very much, take that token. Right, I have a botnet, so I'll try it on this one, coming this way, with this different data, this one with this different data, and see if I can get in, right? You have to think about these things. You have to think worst cases of what happens if they get in. If this authentication route fails, what are my consequences? What am I going to do about it? Are you even going to report it? Right, what else have we got in here? So I'm talking about REST. All of this stuff is automatic, right, up to a point. And they know how to wander through your APIs. So one of the first things to do is not be helpful and to construct APIs. So you can have, if I have a need for an address, shipping address, you know, so a classic example, I have a Mongo database and I have a record in there, a document in there for a client, and it's got all sorts of data. And then I have an API that needs to provide some shipping information. So I go, okay, I'll give them the whole document because that's easy. I don't have to pull stuff out, give them the whole document. So the API may say, give me shipping address, but what I get is shipping address and postcode and favorite color and all that sort of stuff, right? That's just bonkers. So you start creating APIs that are more around the specific use cases, and you put time and effort into making sure that the least amount of data gets shared, right? I mean, you know, that's got ID in it, but even that would be bad. Just the data they need to do that activity, because if that gets compromised, and I've got this set up, and I've got a token for getting user deliverable information, and that's just for that, it can't be used anywhere else. Then, if it does get compromised, well, okay, I know what my compromise is. Otherwise, it could be, well, I've lost all my data because I don't know what they've taken, because credit cards, whatever, was in data I sent to them. And the way that you give the data out, we're very good at being helpful. So we're very good at going, okay, so you want a list of dates, you know, I mean, schedule in this case, Santa Claus's schedule, set of dates. And you go, give me the calendar. And he goes, okay, here we are. Because it's easy. On the other end of this is some software. So, I mean, there's software producing it and software consuming it, yes? But we do it this way because it's easy for us as developers. But that's a bad thing to do because they are scrapable. Tools understand the date field and numbers, right? Bear in mind, they have all these bots that are going, what have I got? Oh, this is useful. Hey, Mr. Human Being, can I come and, wake up? I've got something. Don't do this. Do more like this, where you provide URLs that maybe say, give me dates from a certain range, and then don't return them as dates, return them as offsets or something. We do this in ways that the tools are not going to be able to figure out. And that basically says every time you send out royal raw data, especially dates, then the tool will go, I know what that is, right? This doesn't cost you much more, either producing it or consuming it, but it's much harder for the bots to figure out that this thing that you've designed just for your application isn't about dates. And it's like, if you're giving out credit card details and you're sending some JSON data down a secure system, don't call the field credit card. Basic stuff. Right. I think I may have said this, but every API you use is going to get attacked, and it's going to get attacked in ways that you weren't expecting, because that's the whole point. Can I use your APIs in a way you weren't expecting? The classic one, coming back to credit cards, is the API that's a credit card number validator. So this was a classic for years when people put up a system, especially when REST first started and we're doing microservices. There'd be a bunch of APIs that the front end could call, and it would be like credit card numbers, okay, call credit card validator, valid for credit card, done. People found out that these credit card APIs existed, and they went and got all these credit card numbers they bought off the dark web, and they went, credit card numbers, meet API. Right? And now you're validating all these things for bad guys. So API abuse isn't just about understanding that your API is going to get squidged in all sorts of directions. It's what are you going to put in place to catch the fact that this is happening? Right? Detection of systems, detection of bad things happening is something we're very, very poor at. We're very poor at reporting that. I'm not quite sure about that, because we assume that somebody else will. We're very good at reporting errors, sometimes too good, because sometimes we give out error information we shouldn't. But what happens is we go, that is valid, that is invalid, and that's our choice. But what the bad guys will do, they'll probe you in different ways, right? So you may have stateless microservices, but your data isn't stateless. Your data has state, right? And it could be as simple as the last action that this customer took on this account was this, right? Because you want to be able to say, look, okay, this customer has added $5 to this account, and that's valid, tick. Oh, look, he's done it again. Okay, that's tick. Third time, different IP address. Okay, this is not good. Something is going on. Now, quite often, most often, as developers, we assume somebody else is detecting that for us. But quite often, they can't detect it unless you give information out. So when this sort of thing happens, even if it's not specifically wrong, you should put it out. You should make warnings. That's a large number, or that's happened 5 times. You put information out about that to the logs, then the tools out there that that do log analysis, which are looking for hints about unusual behavior, will have something to key off. If you just swallow it, or you don't report it at all, then nobody knows. What do I have next? Oh yes, how you deal with errors. I said black or white. We are very good at doing this. Who does the try catch semicolon? Come on, we all do it. And the reason we do it is we go, well, either, oh, that can't possibly happen, or I know what the problem is. So, I know, Java code, read a file, and you get an I/O exception, okay? So look, this one says if file exists, then create it, and then catch an I/O exception, right? Well, shouldn't happen. Well, between checking for existing and you going to read it, it might disappear, right? So you can't have well, it exists, therefore nothing bad can happen, right? That's not what you do. You do the file not found exception, because it's a valid exception. If you get that, and you'd already assume that it should exist, what are you going to do? You're going to report it and go, weird things happen, right? Why this is important in this, even in this specific case, is that again, developers are very good at designing systems for themselves, and they used to, quite often we have debug modes or developer modes where we turn checks off because it's easy. And quite often that may be around what's in a config file. So if that gets compromised, your application that should be in production mode suddenly comes up in debug mode, right? And sometimes it's the existence of these things, environmental variables or whatever, that drive that behavior, right? So the bad guys will figure that one out, and they'll try and drive you in different ways. But errors are, look, something strange happened, report it as in this file should not exist, or this file's disappeared, problem, at which point you should bail, because what would you have done if it didn't exist? And then some other IO exception, because there are many. And then you've got well, that's a weird problem, right? So there we go. Oh, and then when you're dealing with errors, don't tell the bad guys too much. You've all seen these sorts of things, right? And when you look at this, the pen testers love you for this. The bad guys love you for this, because they try your API and you fail, and you go away, you did some bad things, and you say the bad things you did were, well, you gave me a number that's out of range. Oh, okay, well, let's see if I try a different number, right? And if you're not logging this, you have no idea that somebody's probing your APIs, and the bad guys are getting closer, right? All sorts of things about what was going on, errors. Java stack traces. From the Java stack trace, I can work out what version of Java thing you've got, because they're all unique, right? And anyway, even if you didn't do that, hey, look what version of Tomcat you're running. Thank you. Has that got vulnerabilities? Well, that one has, because it's old. But you see, you give information away for your benefit, not for theirs. And you do it because you get, oh, well, the customer's had a problem. Oh, there's nothing in the logs. Well, what's the error report, And that's for your benefit, but it gets reused for the bad guys. So you have to think hard about the error information you give out. Give out error information that's opaque to them, useful to you. Right, 9. Well, look, it all comes up to this. Logging, alerting unexpected behavior. And I know it's hard. It's very easy to spot the black and white stuff. It's very hard to work out that something unusual happening. But in all the things that we do, keeping up to date with dependencies, right? That's like number 1, because you just have to do that. Number 2 is taking a very, very good look at your input validation, right? All the ways that your API could be squeezed and dried, and to make sure that you can detect that. And then the third thing is reporting it. Because if you do not report that unusual things are happening in your application, then nobody will know. Because you have your sort of like, you have a API gateway, which is first line of defense, then your application, and then you have any of the log scanning tools that you have, which I assume you have some. They look at the log and they're trying to work out good behavior against bad behavior. If you don't log stuff is happening, they'll never spot it. And as you saw with Log4j, it's not totally easy for me to come in and do stuff with your system completely off the record. Right. And the last one on my list is this one, code defensively, which is sort of a couple of things I've been saying, but again, it's a whole talk in itself. The OWASP guys have a long list. You go look at this and you will come and going, yeah, well, that makes sense. There's nothing horrific, unusual in there, right? Minimize attack surface area. Yeah, that makes sense. What else we got in there? Defense in depth, yes. Don't assume that a firewall protects you. Don't assume that your API gateway will protect you. Plan for, okay, what happens if they get through that? What happens if they get through that, right? Don't trust any of the data that you get given, even data that you give out, because it may not be what you thought. Right? When you talk to a remote service, even if it's something that's next door, still think about what happens if that's corrupted. You can't just say whatever it tells me to do, I'll do, because you're trying to create software. In depth is I don't trust anybody until I prove it to myself that they are worthy of some trust. Right? What else in there? Yeah, fix security issues correctly. Apply your dependencies. Right. I think that's sort of it. We could do days and days and days of this. As you can see, there's all sorts of aspects. But mostly what I want you to take away is just this idea of you have responsibilities as a developer, right? And you need to start looking at how you deal with those new responsibilities. We've taken them away from developers, I think, over the years. We, as developers, used to be more expected to understand how things work, and we keep taking those away. Go, that's somebody else's problem. Well, in the middle of all of this nastiness, you as developers are the critical link, because you know what the application is supposed to do. You chose dependencies, right? You know what the data structure should be like. You know what it should do, right? So you need to now start looking at it from that point of view, right? So so like it's vulnerabilities first, build processes second, it's data validation, and it's about reporting unusual behavior, right? And coding defensively. Okay, well, I'm run out of talk. I'm going to stop there. Are there any questions? Are you all stunned? Yes. Oh, no, I didn't mean that. Hold on. You mean that one? That one? Yeah. Well, okay, so that's a good question. Yes. Oh, sorry. So I think the question was, do you do this data separation at the database, or do you do it in the application? Yeah? Well, ideally, you do it in the database, right? But sometimes that's just not possible, right? And it's your, I mean, I wouldn't say it's your, well, it is your choice, obviously, but in relational databases, it's not too hard to say, and you might actually have, a shipment table, and in which case that's easy. But if you've got a NoSQL type database, where then in which case you tend to blur all this stuff together. So depending on what's those circumstances, it may be easy to do it at the database or not. So if you've got a Mongo database, I don't know if you've got, oh dear, what's the query language? I've forgotten. The, brain's dead. But there are query languages for going to document database and just pulling out the fields. What's it called? I've forgotten. Yeah, anyway, but yeah, so I think it's where can you do it is the first thing. If it's a normal database, then I think it would be reasonable to assume that you would have you could just have a table that you could just pull that out, right? And again, in terms of performance, it's not going to be that much. I mean, either way, whichever way you do this, if it's a call to a database for a specific record, whatever's in it, it's basically the same cost. If you're calling to a NoSQL database, you still get the whole lot back, and then you just strip it out. My point really was that you just have to think about you give zero data out that they don't need. Sorry, can you say that again? Yeah. Yes. So okay. So you're right. So you have to say if the request for users was give me everything user, give me everything API, you might do that. But really, again, I wouldn't. You just don't have this idea of having an API that says give me all the user information or give me all that entity information. Is that what's that for? Because if the end user, the consumer, unless that consumer is the admin is going to edit everything, in which case is still a bad design principle, because you're going, well, if I should be able to have powers that say you are allowed to update the shipping information, you're allowed to update the email information, right? And a lot of this is thinking about how to do it and then realizing, well, actually that's not performance, so we'll take a risk. But so many people just drop into, I'll give them everything because it's easy. And the trouble is it flows, and the next thing you know, it's in a browser because I've got it from the API, and it might go through the gateway, and I've got a bit of JavaScript that's got the data and then formats it. Right? And it's just easy to give them everything than it is to make them make specific calls. Now, one thing you could do in defense is look at things like Hateos, which is the next level up from REST, where you start to have stateful APIs that get returned, and they can be used to say this stateful API will give you just this data, and then your browser can make the right calls because it understands that making that call gets the data I want. So there are other design principles that you can follow, but unfortunately all of them require you to put more thought and effort into it. Sorry, I have no easy answers. It's just these are problems that we have to deal with, and if we don't deal with them and don't start looking at this from this new point of view, bad things are going to happen. So it's not the greatest fun story, but there we go. Okay. Oh, okay. Oh, so I can be blinded. Okay. Okay. Any more? Oh. Yeah. Okay, so the first question was, I talked about the Software Supply Chain Act, or the executive order, and the 2025 date. And it's like, where does that come from? That's a good question. It basically comes from the people writing the act in the first place, and they were making assessments to explain to people what timeline they were on. Okay, so I wouldn't say that there's something that said by this date, but it's getting close to being. The reason they're doing it is like that is because they have to force us to do it. And if they said, oh, by 2040, you'll have to do this, it's way too late. Right. So that was the first one. Sorry, what was the second question? Okay. So what would a proof look like? So by 2025, what do we think the US government and others would be expecting of us? Well, if I go to that slide that I had before, which is this one, it's mostly going to be what's on here. So most of what they care about is the SBOM, and the scope of the SBOM is yet to be decided because it's a technical challenge as to how far we can go. But the evidence and audit processes are quite governments know how those work and what they want. So they are the primary things about. They want to go. It's strong controls, evidence of vulnerability programs, software integrity, demonstration. It's all about straightforward. About you demonstrate. So you have to. The onus is on you then to say to whoever it is that you're demonstrating to them that you have good controls. It's a government thing. Yeah. And this will evolve because there's no way at the moment that we can achieve all the things they want by 2025, and there'll be some compromise, but it's not going to go away. It's going to get more and more because it is it's the only practical thing that we've got at the moment is to have governments forcing it, because we haven't done it ourselves. Yeah. Okay. Now more. Yeah. Can I show you how Maven Dependabot and Maven works in terms of checking dependencies? So Maven is easy. Dependabot, well, you apply Dependabot on GitHub to your repo, and it will send you emails, and it will tell you. It will also raise issues, if I remember, telling you that you have this version and you should move to this version. Right. So the information, it will give you information. What I want you to do is look at that information. I mean, honestly, turning it on, if you haven't tried Dependabot, turning it on is very trivial. It's you go to the GitHub, you go to your GitHub repo, it's a security panel, and there's a button that basically says that. You can go to GitHub Marketplace and find 50,000 other tools from all different vendors that will offer you some security benefits. My point wasn't, because they are trivial to use. The question is, do you know how to assess whether they're accurate or not? Right. So that comes down to you. It's a thought process. So what would you expect? You go to Maven. You go to your POM, and you have a bunch of dependencies. So if you ask these tools to tell you what dependency list was, because that would be the first step, you would run the Maven dependency check plugin, and it will give you a nice structured text list telling you all the stuff you've got, and all the stuff that they depend on, all the stuff that they depend on, so on, until you've got nothing. And GitHub, no. So the Dependabot, I think Dependabot may actually have got that level because it's been updated recently. But I would say you go to Dependabot and you say, does Dependabot report look like exactly the same as I got from my Maven check-in? And then, and this is the thing is that you need to look at how Maven POMs work. And I say you need to go, if you've never done this, set up a multi-module Maven project and play around with the dependency tags and the dependency management tags, right? And try, because you can create your own Maven modules and depend upon them. And you can play around with what happens if I use dependency management. Actually, let me show you something, because I can demo. I'll show you a simple thing. Hold on. Mirror there. So I have here. See, this is the classic. So this is another tool another demo that I've got, and it has lots of dependencies, right? And way down here, this is where are we? Got to find it now. I was there a minute ago. Okay, so you see this one here. So this one here. So Quarkus, this is a Quarkus thing. Quarkus doesn't use log4j unless you tell it. It uses the JBoss stuff. So obviously I wanted to use log4j, so I put that in, and therefore I get log4j as an option, which is fine. That's what you do, isn't it? Okay. And for this demo, that's not good enough, because that thing there pulls in the latest version of log4j, so it has no weaknesses. But I still can make it happen, because if I go way up here to the dependency management thing, you can see in the dependency management thing that I have overridden the version of log4j that Quarkus wants to one that I want to use. Do you know you could do that? But you have to then ask yourself, so if I have a dependency that's using log4j and it's done that, does mine override that? Right? So I'm not going to give you the answer because they're the things you need to try out. You need to go and say, this is about you understanding the tools you use. Right? Because what are the rules? And come on, I mean, more often, what do? We use Git, you know, and we do push and get and commit and stuff like that, and we stick things in dependencies, and maybe we set the version number and the Java version number, and that's probably most we have to do, because so much else is done for us. But now I'm asking you to take another look at the thing that you rely on, and work out whether it does what you think it does, right? Okay, yes. So what's the new 0 day coming out? Well, yesterday, what started to bubble was something called Java Psychic Paper. So it looks like that there is, so it's being reported, and we were just playing with it, and I was playing with it this morning. So basically, what's being said is that there is a vulnerability in the JDK from Java 15 onwards. That means some set of signage into some sort of SSL signing can be compromised, because, and I feel this is embarrassing for many people. What happened was that they replaced the C code version of in OpenJDK. They replaced the C code with some Java code, and they made a mistake, and they left off a bit of checking, and somebody's found that. So in theory, it means that they can get into your system and bypass your authentication, because your code will authenticate regardless. And that's what I have at the moment. There's an argument brewing about under what circumstances. So once we get a bit more data, but from the playing that I was doing this morning, it's like conceptually, this is going to be another nasty one. The fix will be upgrade your server, your version of Java to beyond, to the latest versions. That's it. Yeah, it's because it's 15 onwards. So that basically means 17 for us, right? But just watch this space, right? Yeah, and the reason I think it's a 0 day is because it was reported to Oracle back in November. Right. So if it's really a bad thing, it will have been exploited. Okay, yes. Yes. Okay, so good question. So what does it really mean to say, how do I choose my dependencies carefully? Okay, so there are some technical bits, and then there's some social bits. So the technical bit is, well, so you talked about transitive descent. The technical bit is this: when you choose a dependency, what are you dragging in with you? So to do that, I mean, to be honest, it's quite easy to do. This sort of thing, you can put it in, and you can ask Dependable, or so you can ask Maven, and it'll give you a list of the transitive ones. Or, you know, it can be that simple. And then you get a list. And then you can say, is any of that suspicious? That would be my first thing to do. Then from a social point of view, it's saying, assuming that that dependency feature is what I want, then you've got to go to the open source project. And this is where it becomes vague at the moment, because you've got to make that personal assessment as to whether the open source project is, well, A, that it behaves the way that you would want. If it was you, and and it was your project, do they behave the way that you think? Do they care? What I think is that if the number one is, do they have a vulnerability reporting program? Do they have a web? I mean, it might just be a GitHub page for the project, but does it say, if there are find vulnerabilities in our software, report them like this? That would be the number one thing to check, because if they don't do that, then they're not even paying attention. And unfortunately, most of these dependencies don't. That would be the first one. The second one is that on GitHub, there are pages beginning to turn up that can give you a sense of, I won't say the quality, but the socialness of that project. And again, you have to look at it, and you might want to pick a few of them. You might go, I've said to people like, well, what's your favorite open source project? Go see what, do you trust them? Go see what they do. Go see what they've got. Go look at their the number of committers, the activity numbers. I said there's a GitHub page on GitHub. They've got a new tab, and that starts to give you insight into what's happening in the project. I can't remember what it's called now, but it's like, set yourself a bar and go, I want them to be like this. When was the last time they did a release? When was the last time the source code was updated? Because just because you've picked this dependency at this version, when was the last time it was updated? Because you can't tell with version numbers. You have to go to the GitHub project and see if when it was last updated, because you want vital software. You want to make sure that the project you're consuming, there are people actively working on it. Because if there isn't, then you just bought a black box, right? Look at when the code was changed. Look at, if you find a project that's everything says 7 years old and there's one file that's like yesterday, you go, that's not good. What's going on here? Because if it's all 7 years, and you go to GitHub, you can find projects like that. If it's all 7 years, then great. It's stable. But you take the consequences of, if there were a problem, you may not be able to get things fixed. If it's very old files and there's a couple of new ones, you go look at the issue and you go, was that for a reasonable reason? Is it they actually fixed a vulnerability? Or is it a new committer has turned in and changed something? So that's these social guidelines about looking at what makes a good open source project, and then saying, do the ones that you're consuming have those characteristics? They're not going to have all of them, because sometimes they're quite small. But that, so that's where we go. Now, everybody, Sonatype and others, are all trying to figure out how we quantify that for you to give you some better understanding of the attitude that this software project has towards what's important. But we're nowhere there. So at the moment, you've just got to make those decisions yourself. Yeah, sorry. Yeah. Okay, one at the back, yes. Yes. Okay, so what's best practice for logging exceptions? Well, the first best practice is don't give it to the client. Don't give it to the user. And I know we do that, but you can't do that. What I've seen people do is they'll put that somewhere, and then get some code and give that to the end user, because at least then the end user can say, I got this code, and you can go find the trace or the stack trace. If you give them the information, apart from the fact it looks stupid because you have a Java stack trace, you give them all this information about your system, and they can keep probing. So that would be the first thing. Whether you put it in your logs, how much you put in your logs, because again, the problem is if you log, as you say, if you log everything, the logs fill up with exceptions. So there is a fine path, but I think what I would do now is I would say you turn on, you log all your exceptions. So there are ones that you're going to get. So the first thing, I'd go to your code and go, I will accept that if I get this, it's okay. So they're fine. It's when you have generic catches. It's when you do, try catch exception. It's like, go to your code and go, what actually can I expect to get? and subset that and go, I only want, my example was file not found, but it could be anything. So the first thing is to go back to your code and narrow down to the things that you want, right? And then in terms of which ones will you log, well, honestly, if you don't log them, you won't know you're getting them. So I would say it becomes a circle. You log everything, see what you get, go back to the code and go, why am I getting that? What can I do about it? Change the code, remove the log, and then you'll get down to logging the things that you care about. Because at the end of the day, why you're logging because it's an error and you need to know, right? Or somebody's doing something bad to your system and you weren't expecting it. If you can make that differentiation, then everything else is just noise, and then it's a matter of do you want to log them? But it's exceptions. I mean, the trouble with Java is that we're so used to putting a throws on. We're going, well, we're not going to catch it. We'll put a throws on, and it percolates up, and then eventually somebody catches it. I'd just say our approach to exceptions has to be different. So I would say number one would be look at the code that you've got, and everywhere you have generic exceptions, try to whittle that down. I mean, what you can do is you don't have to log it to start off with. What you could do is start putting some code in that just starts counting. Right? What am I getting? Am I getting exceptions at this place that I wasn't expecting? I mean, because if you're being told off your log's getting too big, then you might start with some system that you put some code in that says, at this point, I wasn't expecting it, but I'm gonna basically log it or count it in a different way, and then you can come back. I don't know if that makes sense. The primary one is don't give any information to the bad guys, and store it away. And then in terms of reducing the number of exceptions, well, I think you just have to work through it. Yeah. Come find me later and we can talk about it in some more details. Yeah. Yeah. Cool. Listen, thank you very much for being a brilliant audience. I'm around all week. I'm doing a talk on tomorrow, apparently, about into more detail about what Joe Bin was saying, and we'll go into that in more details, and maybe some more, actually, sort of a lot we talked about here. So you may not want to come to that one, but I'm around, and if you desperately want to talk to me, then go to the Sonatype booth and tell them, and they'll find me. Otherwise, I'll be wandering around. Right, thank you.